Welcome everyone. Welcome back to stream number 5 already. We'll continue through the nym by example tutorial that we were working through last stream. And I just wanted to remind that if you have any questions, even after the live stream has happened, please feel free to ask in the comments. Feel free to ask during the live stream. I'll be happy to explain, to respond. And if you're watching on YouTube, remember to like and subscribe. Also, the thing is that there are 2 playlists on my YouTube channel. One is a playlist with all the live streams, which is usually 2-3 hour long videos. And the other playlist that I'm slowly creating is a playlist called just Learning Nym. And that contains videos which are basically little shorter pieces of the live stream, maybe with some breaks cut out, so it's a little bit easier to follow. And, you know, they're a little bit more condensed. As the time goes on, I'll be basically taking my existing live streams and simply, cutting them down in those smaller videos, so you can expect daily uploads of shorter videos if you don't feel like, watching a whole live stream. So that's it when it comes to announcements. And let's get back to our tutorial. Last stream we went through everything here on the left, all the way to object types. And now we're getting to some more fancy things like enum types. So let's start. Enums. Enums in nym are like enums in C, but are type checked. So what I understand it as enums in C basically means that we have some kind of name and that corresponds to like a numeric value. There are no anonymous enums in nym. Okay, whatever that means. So let's see. We'll define a type, compass directions, and enum. The type is enum, and it looks like we have all the directions defined here. Okay. And then we have another enum specified as pure. Okay, I hope we're gonna get an explanation. Okay, where they have value, here we have a text value, string, attached to red, green, and blue. And additionally here, the green has, I presume that's the index, so 0, 1, 2. Very interesting. No idea what that means. Other colors are also pure, and we specify it in zeros, I presume hexadecimal. So sure, hexadecimal integers. And then we've got signals, and that's not a pure enum, just an enum. And we have signal quit is 3, abort is 6, and kill is 9. Okay, that makes sense. It'll be interesting to also notice that both colors and other colors, they have same, this one has red, both have red, and other labels are different. Okay. So, echo red, error, ambiguous identifier, red. Ah, look at that. When we'll try to print out the color red, yeah. Ambiguous identifier, red. Really, but we just said color. Red. We'll need to check that. Other colors, red. Apparently it doesn't mind it. Oh, wow, I'm so dumb. They just commented it out here. Okay, echo red will be confused because it doesn't know if we're calling from colors or from other colors. But what is important to know that it would try to figure out which we're using. So when you type in red, it doesn't look just for a type name red. It's smart enough to look for it inside the enums, which is nice. Here we can specify it specifically. Hey, use colors. We'll do it. Other colors. Red. Yep. And then we echo the orange. Space. And just orange. And it will be smart enough like, hey, we have orange only here. So it should work. So there we go. So looks like for the first one here, calls red, if we specify the string for it and we echo it, it will actually echo that specific value instead of it. So instead of saying red, it just shows the string. Here when we say red, it completely ignores the value. It just prints, hey, the label. And same here. Notice that each element in compass directions is prepended with CD to avoid name conflicts, since references to enum value do not need to be qualified. Okay. The pure pragma that colors and other colors have requires that all ambiguous references to the enums values be qualified. This means that orange can be referred to without other colors.orange, although all other colors.orange is still allowed. Okay, so without that, compiler would assume which red? That is a little bit confusing here. And enums can be given custom values and stringify values as shown by colors and signals. Yeah, in colors we gave it this, and as signals we gave them values here. It still doesn't explain what is this thing. Because then we just go to ordinals. That's not a great tutorial for enums, I'd say. Let's copy that code and play with it a little bit, so that maybe we can understand what's going on here. So let's get to our code, whatever I was doing here. And let's open our recent, which was here. There we are. So when we save it, compass definition is declared but not used. Okay, and the same thing with signals. We don't worry about it right now. So what happens if we'll remove that pure? Save it, it still doesn't mind it. We remove another pure and save it. It's fine. Well, what happens if we do echo red? Type mismatch. Okay. So it doesn't mind that, even though it's not pure. But here it says type mismatch. And if I'll say that they're both pure, it'll say ambiguous identifier. So the only difference seems to be that type mismatch. Expected one of the first mismatch of positions. So normally it just shows really confusing message. Same thing if we'll try to do that. It will be just type mismatch. Oh, the red is colors or other colors. So, still not sure about the whole pure. Shouldn't it be by default? Let me grab our AI helper for a second. Maybe that's gonna explain it a little bit better. So let's bring our previous conversation and what is the pure pragma when it comes to enums? What is the AI explanations? In NIM, the pure pragma is used to mark enum as a pure enum. When an enum is declared as pure, it means that the enum values are not implicitly convertible to integers. Oh, and they do not have integer-like behavior. Here's an example to illustrate the difference. So we have type color, which is enum, and then we have pure color, which is the pure enum. And here, I guess for an example, we just don't have anything overlapping, okay? In the above code, color is a regular enum, while pure color is marked as pure enum using the pure pragma. The key differences between regular implicit conversion to integers. Regular enums can be implicitly converted to integers. For example, red has an ordinal value of 0, green is 1, and so on. Okay. Pure enums cannot be implicitly converted into integers. They are treated as distinct values without an associated integer representation. Ooh, I like that. So you can do sneaky math here and there. It's just, sorry, you can't do that. No trickery. Nice. So I would presume those would be nice as a default implementation, just to make sure that compiler won't let you do something weird. But if you have something where that math would be actually useful to have there, you know, this for flags or whatever, then definitely not pure. Integer-like behavior. Regular enums support integer-like operations such as comparison, arithmetic, and bitwise operations. Okay, cool. Pure enums do not support integer-like operations. Yep, they can only be compared for equality and inequality. And compatibility with integer types. Regular enums are compatible and can be used interchangeably in some contexts, while pure are not. Okay, so the pure enums just provide better type safety and prevent unintended mixing of enum values with integer. Exactly. So yeah, that's that. If we'll try to do color and ordinal, yeah, we'll define C as just the value red. It'll just give that 0. Well, if we'll get pure color here, it'll be sorry, cannot do that because I guess we didn't define what to print it as. Huh. Oh yeah, because ordinal. Yep, it can't do the ordinal. The same thing for normal non-pure, we can add one. For pure, we can't. Okay, so let's see if their explanation makes a little bit more sense now. So let's see. The pure pragma that colors and other colors have requires that all ambiguous references to the enums values be qualified. Without other color. Okay, this is still confusing, but it for sure helped with when we were trying to print red, because in both cases it just didn't indicate that there's a problem with the enum value itself, that we need to qualify it, but go figure. Let's move on to ordinals. While enums can also have disjoint values, it should not be used for any other reason than compatibility with C, because it breaks the idea that enums are ordinal. Can also have disjoint values. Huh. Okay. So for direction in ordinal of the smallest, I guess the first element of compass directions to the last element of compass directions. Okay, so we can call low and high on the type compass directions, and that will give us the first and last. Fancy. And it's a range. So from here to there. So I guess ranges work also. Oh, because it's ordinal. So we'll just give it indexes. Huh. So we can say echo compass direction, and we take that number to give it the number, which I guess it will be kind of like index, and what number that is. Okay, so that will print out basically 0, 1, 2, 3, 4, 5 or something. Let's just do it like this. This was pure, this one's pure too. We save it, and when we run it, we get, the name of it, 0, 1, 2, 3. So we called here, this is 0 for the first one, the lowest. And we call compass directions and 0. It will just give that as that thing. And by default, that will be, a value. Okay. Very cool. And then we have the ordinal type of low of integer. That'll be smallest integer, and we can increase it and decrease it, and we can echo the highest value for the character. Why is that here? Because we do increase and decrease on ordinal. That's fine, but we are not using the value anywhere. Okay. I guess this is just to show that we can increase and decrease value of something. Okay. And the highest of character will just return the last character. I guess, yeah. Because enums are ordinals, they have the low, high, increment, decrement, and ordinal methods defined, where low gives the lowest possible value, high gives the highest possible value, increment increments, DC decrements, or D gives the integer value of the enum. Compass directions is a cast that gives the enum from an integer. Okay, plain and simple. It is also possible to iterate through all possible values of ordinal enums, either as shown above or from this to this, which is equivalent. Oh, okay. Because CD North has value of 0, while CD West has value of 3. So we'll just go for it. Okay. Same thing here. And signal quit was what, the last one? No, that's not the last one. Okay, but this one is 3, this one is 6, this one is 9. So this wouldn't do much. Signals is not an ordinal type, and so doesn't have the increment and decrement procedures. Wait, signals isn't? Because we specified those values? So I guess this code just wouldn't work, right? And if we paste it here, save it, it's fine. When true. Save. Oh, wow. When it was false, it just ignores the compiler, completely ignores the whole chunk of code. Oh, because when, that's compile time. Okay. And now it says expression inc non-ordinal. Expected one of the first mismatch positions. So it was basically expecting the ordinal type. But because we have those value sets explicitly, it's not an ordinal type anymore. Okay. Can we do ordinal of that? Save. Now it'll be fine because we converted into integer specifically. So signal quit will be echo. We do quit, and we'll just give the non-ordinal. Save. Now says it's 3. The other one, abort. Abort will work. Okay. So they have those values attached. It's just, you can't iterate over it. You can't just increment, decrement. Okay. So that's only if we don't have values. Alrighty. So if I will remove that again to bring it back to normal, what it was, right? Now it's complaining about that. But if I would remove this and that, now it works because only one of them specifies as number 3. What if we'll say that, yeah, number 3. Can I iterate over them? Let's say from signal quit to signal kill. That should iterate over all of them. And instead of that will be signals and whatever direction or something, and ordinal will be that. Save. Suspicious code enum to enum conversion. Wait, what? Enum to enum conversion. Yeah. Oh, because this gives a signal, not the actual thing. So we do this here. Let's just rename it signal, right? And we do ORD. So when we run that, we should signal this and that. So that means that they went 3, 4, 5. What if I'll change the declaration from declaring this one to be 3, but this one will be 2, 3, 4? No, now it's like, I have no clue what. Ha. So we can define only the first one as some kind of value, like 300. And it's fine. Okay, 300, 301, 302. But if we'll define it somewhere in the second or last one, it will be like, no, I have no idea what I'm supposed to assume here. Okay, makes sense. But if I'll make it as 3.5? Huh, won't go through. Okay, makes sense. We learned something. Okay, so that's it when it comes to enums. Let's continue with distinct types. Distinct types are like other type aliases, but they provide type safety so that it is impossible to coerce a distinct type into its base type without explicit conversion. Yes, I remember that in one of our initial tutorials, so we can specify that we want to type $, and it's a distinct float, so it won't be like automatically assumed whatever value you give it to be $. So if we can create a variable a and say it's 20, and we convert it to $, okay? Because this is, we need to remember this. Let me just copy it. Need to remember that. What the? We need to remember that this here, this called $, with the dot, is the same as this, or the same as this, right? $20. Could do that, no problem. Or just $20. I'll be happy. And here, this doesn't compile because this is an integer, and it's like, you can't put integer into distinct float. If you would try to put 25.5, again, it doesn't compile because the float 64 is not the same thing as distinct float 64. Okay? It will work only if we'll actually convert it to that specific value. So, you know, we can't just misuse it suddenly. Okay. However, when using distinct types, none of the base type's procedures follow the type. To solve this, it is possible to create lots of procedures that basically act as a thin wrapper for the underlying types. Or the borrow pragma can be used to automate generation of procedures. So we can say we do multiplication. We define the asterisk what do you call it, operator that takes A and B of dollars and returns a dollar. And when you specify borrow, I guess it will look up that, hey, this is a distinct of this thing. And if this float in this case has the multiplication defined for it, it will just try to borrow it and do it. I really like that. Okay, because I was already wondering, like, you know, it's really fun to be able to do that, but do I need to define all the operators suddenly? What about math? That's another thing that I'm not sure about. We could test that, right? If math would work on that. So let's see. We have all that here. Let's remove those doesn't compile or something. We have our procedure multiply and add borrowed. So suddenly we can say that the variable A is $20 times $20, or just plus, right? Echo A. Expected 1. Okay, so I guess we will need to do also define the dollar operator, right? And we do basically the same thing. We just do A dollars and returns string. Save. And now we can print it out, right? So let's see. There we go. 40. Bam. I really like that. But of course, if we wanted to make it a bit nicer, we could do equals and we do just A the float, I think. And we just add the character dollar sign in front of it. We just save, and will that work? There we go. $40. There we go. We did it. We properly render it now, while reusing the way the float is being formatted. Okay. Gosh, that was so easy. Okay, what's next? When creating a distinct type from an object type, none of its fields are carried over. If the fields are wanted, they can be brought over through an overloading of the borrow pragma. If they are not borrowed, they cannot be accessed. What the hell? So, we define the type foo, which is an object that has a field A, and then I want to say my foo is distinct foo, so again, they are not directly compatible. And we do borrow and specify the dot operator. Oh, so the dot operator is so that we can call this. Oh, wow. I must say this is weird. And I wonder if you can define your own pragmas. That would be something crazy. But okay, so we can basically... It's just some gymnastics that you need to remember when doing that. That's too bad. That's a bit too bad. I mean, at this point of my knowledge about Rust, which I mean about Nim, is so little that, you know, I don't know what is the reason for it. But, you know, that's just me right now. Okay, so we went through the distinct types. We're going fast. Let's continue to strings. And that might be a little bit more fun. So what do we have here? Print out, and we have text, words, 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 and we can just add a little emoji or something. And that will just print it out. Okay, so we can put in Unicode characters. And then echo, we have triple thing. We start a new line without any indentation whatsoever. We end here. Here even have an extra space. And bam, so it should also print all the way to here with an extra space. Ah, they cut it off here. I'm sure it will print with that. Let's copy it and see. Because if it doesn't do that, I will be doubting my skills here. Okay, let's print it. HTML. Okay. Yes, there is. Oh, great. It's just my terminal allows for that. Okay. So it's after it will print this thing. Okay. And let's see if it works. Yes, there is that space in here. Okay, so it doesn't trim anything. But what I want you to notice is that here we have one line. You know, here the echo adds the new line symbol. So we start for another one. And this line from here to here is ignored. Because we just print it out here and we have only the thing that came from the first echo. And bam. So just, I presume for readability, this one here is being ignored. Okay. So, continuing. We can define a procedure, RE, that takes a string and removes it. And it just returns S as a string. So we can just print R as in, I presume it's a raw string, right? Therefore it will be dot this, that. Okay, this is confusing. Yeah, no. Oh, because I guess raw string escapes just the quote and nothing else. Okay, so it'll be period. This is a single quote and period. Okay. And RE, it's a very interesting way of calling it. You can just define a procedure that just takes string as an argument and returns it. And that should just print that, right? Yep, just printed that out. So that's also like our own thingy here. There are several types of string literals. Quoted strings, created by wrapping the body in triple quotes. They never interpret escape codes. Oh yeah, because look at that. This just printed /n/n. And here also, I mean, /n. Okay. So we can easily put in HTML and other fancy stuff and nothing's going to get escaped. Raw strings created by prefixing the string with an R. They do not interpret escape sequences except for the quote itself, which is interpreted as single quote. This means that this thing is interpreted as just what's inside, no shenanigans happening, instead of failing to compile with a syntax error. Okay, because I guess you don't have the B as a symbol. Okay. And then proc strings are all strings, but the method name that prefixes the string is called, so that this is that. So I guess if we'll just make it, let's copy the whole thing again. I already had it. So right now we're just returning the same S, but what if we're gonna just wrap it in something just for fun? So RE will actually add the can I do that? No, I would just need to do this. And this should wrap the whole thing in quotes when printing. So it should print actually this. So when we run it, what? There's a quote. Oh, I see. Look at that. Here it just took 3 and ended with 3. So I guess that means that if I want to have a string with just a character quote, I do this. Just a character. Okay. It makes more sense, right? So let's do it again. And now the result of this is that just in quotes. There we go. Okay, that works. Cool. So you can basically define your, let's call it double, that takes a string. And we just do S and S. So we can double, we can do probably operations, replace things, escape something to, make it safe, and just do call like that, which is awesome. Is it different than this? I guess it's not. That's it. I guess the quote is... Oh, let's save it. And let's run it. What? I guess this is backspace? So, oh, I see. So if we have that space here, it literally just calls the method and takes this string, and this doesn't have any R or anything else in front of it, so it's just being called, consider a normal string. So it's basically backspace, this thing, and backspace, which already converts, if you would shorten it, it'll be backspace, this thing, and just backspace, which removes 1 plus. But when we added with another one, this another starting backspace removed another plus, and I just printed it out. But for some reason, it has that extra plus there. So I have no idea what it means. Okay, but if we remove the space, it should be fine, right? Yeah, now it just printed the whole thing as raw strings. Okay, so the little space is very important here. Okay. Alrighty, so let's see what is described about it. We've got this, Strings are null terminated, so that C string foo requires 0 copying. However, you should be careful that the lifetime of the C string does not exceed the lifetime of the string it is based upon. Interesting. Okay, I guess we shouldn't worry too much about lifetimes, but C string is... So, because nym is compiled to C and it's designed to, work with C very well, it suddenly, all the strings have that extra null character at the end that tell that it's the end of the string. So when we just use string, or something like that, nym knows to ignore it, knows to print it out, knows to, not iterate over it when we're iterating over characters. But it's quietly there. It's just, if you use C string, then you would, I guess, could iterate over it. Because it's like, hey, I'm dealing with C, so don't do additional checks or whatever. Compile my text really nicely. Or when you're sending that to that DLL, send the proper value. Okay. Strings can also almost be thought of as a sequence of characters with respect to assignment semantics. See sequences for the possible manipulations. For example, we can echo the ABC, and so this is, like a sequence of characters, and take the first character. Or return a subsequence. The same thing from, from the first to second to last character. Awesome. Yep, here's an example. The string utils module provides procedures for handling strings. So let's see what examples they will show us. We import it first, of course. So we have variable A, hello, welcome friend. Just no space here, which is ugly. No capital character here, so I don't like it. The split procedure takes a sequence of characters and splits a string based on them. So we can print a.split with spaces or commas. So when this will split it will split here and here. I want to check what happens if I will put that extra space there. So let's take that. If we'll save it and print now, let's just make it a little bit lower and print it. Hello, welcome, and friend. Okay. What if we'll add that extra space here? What's going to happen? Look at that. We have hello, welcome, and empty, and friend. So what if we want to clean it up? Echo, let's say that A, let's actually say A equals A.split. All right. Split it. And didn't we have also something where map? Oh, I know, that was in sequence utils. And we could do map. Is there where or filter? Yes, filter. So we want to send false to the strings that are empty. So this will be the S as a little string. Then we have to use this whole sugar thing here. Import sugar. And then we'll be able to take S and say that it's S is different than empty character. And something really doesn't like it here. Filter A, proc S equals result. But expected a string. What? As is character, and this is a string. Oh, wait. This should be... Oh, so yeah, this is a string, and somehow we could split it, and it would... huh? A sequence of strings. I guess it can automatically... No, it's unhappy about that either, right? So we just need to var be words. Is that... Right? Now it's fine, because it's a sequence of string. So we can say that words is words and filter them where S is not null. Okay? And when we echo words, we should have this just without the empty one here. Will that work? Yes. Oh, that's awesome. I wonder if I can make it like into not empty or something. I'm doing those little programming things here as, you know, I'm learning right now. And I'm showing it on a stream, so, you know, I have an idea of, hey, maybe I'll just, instead of simply reading the tutorial, I will try to apply things I learned so that I won't forget them. So let's say that we want to define a procedure that basically we can apply it on the sequence, say, let's say words without empty or something like that. So to will be without empty. So we'll define that it takes a strings, and that will be a sequence of string, and it returns a sequence of string, and it will be basically strings dot. I will just apply the filter here. And it just returns that. So here we can just say words dot without empty. Save it, and it should work the same. Yes. So if we'll suddenly do something where our welcome is like this, it should still print out those 3 words. Awesome. And we can split those words dot map, where we take the word and we do word dot trim. What was the name for it? Something with S. Split substring. I recall that there was this whole thing that removes trim. What was the word for that? Fine, format, insert. It wasn't normalize. Bunch of splits. Slurp. Huh. What does the slurp do? Won't show anything. Splitting starts with strip. That was the word. Okay. So this way, even if you would have something that has some white space, even though it shouldn't, but let's say we had this, it should remove that white space, right? So if we'll do that, it just removes them. If we will suddenly do this, I'll have one of that in here that we don't want. So yeah, this cleans it up. We split into words and remove duplicates. So we can literally say proc into words, and we take a text, which would be string, and we return sequence of string. And we'll literally take this and it will be, don't need that, right? We can do A. Instead of A, we have text, split, and then map the words so that we strip each word. And then all of those words we can just do without empty. Save it. You can echo words, echo A dot into words. Save. Run it. And there we go. Just like that. Much simpler. Okay, that was fun. And then we have the contains procedure determines whether a string contains a substring or character. Yeah, we can check if it contains hello, and yes, it does. Alrighty. A note about Unicode. Unicode symbols are allowed in strings, but are not treated in any special way. So if you want to count glyphs or uppercase Unicode symbols, you must use Unicode module. Okay, so there is a module for working with Unicode if you expect that that's your input. But if not, if you just purely work with, simple ASCII text because, you know that you're not dealing, let's say, with user input or whatever, you can just deal with ASCII, which I believe will be more performant because, it doesn't need to do million checks if uppercase to, treat all those different symbols. Okay, I really like it. It's not like some other languages that, have specific types. Specifically, oh, this is Unicode that we're working with. Oh, this is C string that we're working with. This is yet another kind of string that we work with. It's simple. So singles are generally considered to be encoded as UTF-8, so because of Unicode's backwards compatibility, can be treated exactly as ASCII with all values above 127 ignored. Perfect. Arrays. The arrays in NIM are like classic C arrays. Their size is specified at compile time. It cannot be given or changed at runtime. Okay. We went over that a little bit. So we define a type, 3 string addresses, and it's an array of 3 elements where they are all strings. Okay, so they will be index 0, 1, 2. We create a variable names, 3 strings of type that array, so we don't have to retype it again. Okay. We could just copy and paste that instead of here and will still work. And we create an array. So we have normal square brackets and we put those 3 names. Then we say addresses, 3 string address, and we have the same thing. Okay, what is the difference between those two? I don't see any difference. It's just they need to be 3. 3 elements in there. The size of the array is encoded in its type and cannot be accidentally lost. Therefore, a procedure taking an array of variable length must encode the length in it and its type parameters. So if we want to have zip A and B of array I and T. Okay, so this is generics. We didn't go through that yet, right? Or we did? Generics. We might have touched on that in the last stream, right? I think so. So this is very interesting because I guess I'm not used to a situation where you specify that not only the values that the array is holding, but also the number, and that number is generic. That is very interesting. So yeah, that's fun. And then you say it returns array of the same number of elements. I wonder if you could do I plus 3 or something like that here, so that it's pre-calculated or whatever. And tuple, which are tuples of all that. So let's try it. Let's try to see if we can add this plus in there, because this is fun. I must say this is the first time where I'm actually going through a tutorial, copying the code snippets and trying to break it. So let's save it, and it doesn't like it. So we created that zip. Yep. And for we iterate over, lowest possible value of A. Oh, with the lowest element of the A array to the highest. I will basically make sure that each element of the result, the new return variable, because I guess it pre-allocated that array type into our result, the hidden variable, and we just assign a tuple that contains both of them. So, a classic zip. But what's going on here? We let name and addresses equals names. Where did names come from? I see. It was in one of our previous examples. So let's copy this thing and just shove it up here. Right? So we define it as that. Save it, and now it doesn't complain. Okay. Let's do echo name and addresses. And let's see what we get as a result. Okay, so we have first tuple, second tuple, and third tuple. Okay, simple. So let's try let's say that at the end we're gonna add 2 more elements. So we'll do result. It'll be high of A, which is the last. How do I turn it into an index? I is the low of A and high. Okay, so low and high will return an index. It won't return the actual value, it's just an index. Okay, so result will be high of A plus 1, right? So let's call it let highest index or max index, and that will be this thing. So we can do max index plus 1 will be, let's call it hello there, right? I'll do another one, which should be, let's say 2, and another one should be 3. I will just add those 3 values. If I'll try to run it now, I expect to have compile error here because we're trying to, add something to an index that doesn't exist. So if I'll run it, there we go. Execution of an external program failed. Unhandled exception, index 3, not in 0 to 2. Yep. So can I specify this will be I plus 3? No. Come on. One is type description, one is I wonder how to do that, because I can see it as, a decent use case where we want to, let's say I want to have the procedure that does something and returns an array that's, combines two of them or something. Let's ask AI if we can fix that. I have the following code. Let's paste it here. Please tell me how I can specify the return type to return an array with extra 3 elements. My attempt with I plus 3 doesn't compile. That's a tricky question. If this is gonna answer correctly, I'll be surprised. To specify the return type of the zip procedure to return an array with an extra 3 elements, you can use a generic parameter for the array size. Here's the modified code. So ITN, and we have static. Oh, N is some kind of static integer. Very interesting. And therefore, then we have our A, B, and then we have the return type already specified as N. That's not it. And then we need to assert array size might be greater or equal than this. Wait a moment. What is this static? Doesn't mean that that part will be executed during compilation, like a compilation check? Gosh, this language is getting better and better. If that's true, wow. Let's see. Let's replace our procedure here. Save. Now it's unhappy about T. Type expected. Cannot instantiate T. Server failed. Everything failed. Let's just run it. Type expected and 646. Line 646. Oh, so where's character 46? Column 46. 46 is here. Okay, I don't understand what's the problem now. Because we say that there's I, T, and N, right? Now we say this is I and T, both of them. And then we have N. We have tuple of this and that. And suddenly the T isn't going through. I don't think this is trying to assume that I and T are both static integer. Interesting. And we could iterate from I to N. Wow, that is so strange. But that means that I is also expected to be an integer? And because of that, it thinks T is an integer as well. Oh, so well, if I'm gonna do IN, comma T. Save. Oh, better. Cannot instantiate N. What the bleep? Oh, so let's make it actually a first one. So that oh, no. Okay, I don't know. Let's ignore that. I'm going way off here. We just know that we can specify that the same length. Okay. Alternate methods of indexing arrays are also allowed. And the first type parameter is actually a range. Just a value, as above, is synthetic sugar for 0 to n minus 1. So it's also possible to use ordinal values to index an array, effectively creating a lookup table. I just got an idea. Wait a moment, where'd it go? Let's get to our original definition, right? This was unhappy because of the I plus 3. But now we know that I here is a range. So what if I'll say that it's from 0 to high of I plus 3? Expect one of first. So I is. How do you find range? Range of integer? Nope. Again, nothing works. I thought that would be smart, but nope. Never mind. Okay. So let's see. So just a value as above is static sugar for 0 to n minus 1. It's also possible to use ordinal values to index an array, effectively creating a lookup table. So we have a type, parts of speech, which is a pure enum, so they don't have integer values. And we have all that. Let parts of speech examples, an array of parts of speech. So even though they don't have the values like, 0, 1, 2, 3, you can still use them here. And we specify that they map to a string. That's interesting. And therefore we specify this. So we can call later echo parts of speech, and in brackets we say adjective. Nice. So do we use the parts of speech anywhere? No, let's see. So let's get rid of that. We have parts of speech. So echo parts of speech examples. If we'll print that, we're gonna just get those values, right? But nothing stops us. Echo parts of speech verb. Save. And run. And we get reads because it knows the verb maps to that, even though it doesn't have any specific, integer value. This is powerful. Okay, this is very powerful. I really like that. Type. So I specify type mate. Ooh, okay. Here we have a static that isn't explained. So define matrix. So I guess we're going to math, something I really don't like. Width and height, and I presume they're both static. They're both static integer. Equals array, where 1 to w and array 1 to h and integer. Okay. Okay, so it's an array of arrays. That's it. So matrix 1, we just define it as being, it has width of 2 and height of 2. And then we open and close it here, and we have those two values in there. Okay, that makes sense. And then the other one, and then we can define plus on that, where they're both matrices of the same width and height. Okay, so this, I guess, infers that both width and height are of the type static integer. Okay. And for I in 1 to high, to high of A. So iterate over it, and we just add them. Okay. Very much like it. And I guess here the printing is defined. So just skipped so we don't have to have it here. So let me grab this and go for yet another attempt. Because I just for some reason can't give up. And we grab this just to have it up here. So let's say that this I is static, and we just let's say static, and integer is in those brackets. That's different. Okay. What? Now it's fine? Why? Why now it's fine? Because I should be able to define just that, right? Static integer as well. Save. And it compiles. Let's grab that code and ask what the difference is. Where is it? Here. What is a difference between static int and static int in the following context? And send it. They have the same meaning and can be used interchangeably. The static is a keyword used to specify that a parameter or variable should be evaluated at compile time. It allows the value to be known and used during the compilation process. Okay. When defining a generic parameter with static, you can use either static int or static both. Basically, is the same thing. Okay. Directly specifies that generic parameter is compile time. Oh, so it's just a shorthand. Okay. Good. Let's ignore the rest. So we can just specify it like that. And this just shows I in there because it isn't aware of a range. So this will work only for arrays where the whole thing is static. I mean, it's just an integer, not something else. So in theory, I don't think we could put an enum here. While if we have this thing, now we can put an enum in there. Okay, I see the limitation. I think. Because if we want to add, zip to enums and we want to add additional values at the end, suddenly we can't, because you can just add new values to the existing enum. But let's say that we want to just work on integers, right? We're not doing anything fancy. And we do from 0 to I. And he'll be from 0 to I plus 3. Save. Oh, now it works. Look at that. And we can say that the whole thing, result of I A plus 1. And we just, what was it? Hello world. Whatever. And we just do it 2 more times. 2 and 3. Let's do just echo. And let's try it now. There we go. We did it. We have first one, second one, third one, and then we have hello world, and hello world. And it's all arrays which are basically with, like with a static number, with a number of elements that is predefined during compilation time. Okay, I'll call it a small success. And yeah, this is the thing that helped us here. So I must say this is very powerful, that we can specify those parameters and specify those, using those arrays, where we can just do that and we'll basically constrain the size of the whole thing. This is pretty powerful. Not the most intuitive, at least for a newbie, but at that point it's really nice. All right, let's go to the next topic. Sequences. I think that sequence will be the thing that I use the most, I think. So sequences, abbreviation from sequence, provide dynamically expandable storage. So if you're working with C# or you're working with, JavaScript, in JavaScript this will be probably arrays. Although I don't expect it to allow different types to be stored. But with C# that would probably be a list or something like that. There are two ways to create sequences, with the add operator and with the new sequence of type T and a number of elements method. Once the sequence is created, it can be modified using the add, delete, and add which item and delete which index. The length of a sequence can be found through length and the maximum index through high. So I guess that would be low and other stuff. I mean, low will be always 0, I presume. The standard items, T, and pairs, which is tuple of the index and the value. Operators are also, iterators are also available. Perfect. So we can create two variables. A, which will be a sequence 1 to 3, which will be a sequence of integers, I presume, with a specific values already, 1, 2, and 3 in it. Then sequence B, which is a new sequence of integers with 3 values, but they are all like default value, right? Nothing added there. Okay. Simple enough. So then we can iterate over the A to get an index and a value. And we can modify the B by replacing items 0, 1, and 2 with that value squared. So at this point, B will be 1, 4, and 9. Okay. And then we go over elements 4 to 100. We'll basically add 100 squared ones. So we'll continue. Okay. Because we can extend B to have new elements. And then we delete the 0 element and takes end time. Big O end time. So that's perfect. So yeah, it basically needs to shift all the elements that exist. So if we delete, that means we don't simply take the first element and 0 it. It means we completely delete it. Okay. And then we can define B as first element of 0 concatenate with B. So it'll be, okay, same as original B. I guess this here, right? Because we replaced it first. Okay, makes sense. But no, it was, yeah, because 1 squared is 1. Okay. So let's take it and see at every step if I made a mistake or not. So let's do echo. And we say B. And we print the B. After first step, we should see the new B. And then we have another one. After delete, we should be without an element, and the end will be just like before this one. So let's run it. Okay. It's a little bit confusing. So we start with 0, 0, 0 right here because it was a new sequence, so all the elements were zeroed. Default for integer 0. Then we have 1, 4, and 9 because we assigned indexes from A, which is 0, 1, 2, same as here, squared value of that I. And then we basically went and added 100 more, which is all this. And we printed it. Then we deleted the first one. So instead of starting from 1, we're starting from 4. And then we start from 1 again because we added the first, we concatenated just the first element with the rest. So compiler is smart enough to figure out like, hey, this is integer. Well, this is a sequence of integers. So if I concatenate, I guess I just make sure it's still a whole sequence. Very, very nice. I really like that. So you can add at the beginning of the list. I wonder what the performance is. Yeah. In JavaScript, it would be not fun to do that. You will need to use that whole whatever the. I never know what those array operations in JavaScript are. You would need to do something like B is, and you could do A 0. Now you would need to specify that that's an array, comma, and then I think something like that to just extract it. So yeah, I really like that. Compiler figures it out for you. Cool. Immutability. Sequences are dynamically allocated, as in allocated on the heap, not the stack. Okay. But they're immutable unless marked as var. That means that if we'll say let A and give it a value, we can't extend it. Yeah, it will fail because A cannot be assigned to. However, if we'll specify it as a variable, we can do that. Will work without any problems. Sequences passed as argument by value are not modifiable. Sequences passed as argument by value are not modifiable. For example, the following will fail to compile. So we have a procedure that takes a sequence of integers. And if we'll try to save something here, it won't work. Yeah, we need a var here, specify the input variable. Okay. Sequence arguments can be mutable if they're passed as argument by reference. So, for example, the parameter is annotated with the var or ref. So, yeah, if it's var, this requires this here to be var as well, which is really, really nice. So, I really like that because, you know, compared to Rust, where you need to go the whole gymnastics of borrowing and, you know, passing the ownership, here, it's as simple as, hey, this thing is a variable. I explicitly expect it to change or be changeable, and therefore you can pass it everywhere. But if you'll just set it to let, it won't let you change it anywhere, wherever you're doing something. So that is interesting. Although, I want to check something. So let's say we'll take this code, okay? We'll take that code, and here this works because we specified this as a variable, right? What if I'm gonna make it let? We'll save it, it'll be unhappy. What if I say var other, or like this sequence is, let's say, let's sequence. We'll rename this one. We'll save it. Ah, look at that. Now it'll let us change it if we actually respecified it. So let's say here that echo let sequence is, and we'll print it And we do the same thing, just with this sequence, right? In the beginning, they should be both the same, right? Exactly the same. But if I'll change this sequence, will they both change? So let's try to run it. Ah, look at that. So first thing, they're both all zeros. And the second one, this happened. So what we did here, when we created another variable equals let sequence, we copied it. We copied the whole sequence. We didn't copy the reference to it. Even though it lives on a heap, we don't operate purely on a pointer to it. We actually do the proper thing. That is nice. Nice. Okay, and I'm sure at some point we can deal with references and we could actually copy the reference to it as a pointer. I just don't know how to extract a reference to it. If we would say that this is a reference to a sequence of integers, right? We'll save it. Can I do something like this? Nope. Because I recall that's how it worked, but I don't know how to get the reference of it. Like this? Nope. I have no idea what I'm doing. Hey, let's ask chat. Because I don't know this if this will be explained anywhere or not. How can I declared a let variable of type sequence of integer? How can I get a reference to it? And I'll say that I mean reference sequence integer. That should give us some kind of explanation. This is the address operator. Okay, so it's a pointer to a variable. So it's just address. So let's try that. ADDR, right? Type mismatch, got pointer sequence, but expected let sequence. What? New sequence, which is integer of 10. Where's the AI thing? So if that sequence, numbers, address numbers. That should work, right? Why doesn't it work? Hmm. I mean, I understand that we can't print it now. We could just do this. And we could do this. And this. And just screw that. This is the reference. And we can just pass it like this. Save. Still, let sequence is unhappy. So let's say I have something it didn't work. The error is and type mismatch. Let's see if we'll figure it out because this is really confusing error. then we cannot directly obtain a reference type form from a let variable using the address operator. The address operator returns pointer to the variable, not a reference. Enum ref types are typically used for heap allocated objects, while pointer types are used to that. If you want to create a refs, you need to allocate it on a heap using the new keyword. Okay, so I can't just break the whole thing. I need to explicitly specify it from the beginning. And at that point, I have that main reference from which I can get the concrete type. Okay, I guess that makes it impossible to define something as let with let and then do shenanigans with it. Wait, how did you create the new sequence? New sequence of that. And I couldn't specify this thing. New sequence of integer, right? 10. Save. Nope. Save, this is fine. Can I do 10? As if I was calling a constructor? No, I cannot. So I would need to do for I and 0 to 9. Or wait, I could do that. Let sequence add. And we do the 0. And that won't compile because we need this whole thing to be that way. Now it should. So this way I define let's sequence as, oh, what if I'll do that? And now we'll be happy because we have a, it's let, so I can't do that. Huh, this is very interesting. So this will work only if I actually have this whole thing, but yeah, so I already have this as that reference, right? So I just pass on a reference, so they both will be the same. Yeah, so this will work, and the sequence, taking a reference, I just wonder if this will actually modify the whole sequence properly or not. What's going to happen? Yeah, that modified the thing because we actually got the actual data and we modified it in place, I presume. And because of that, this is still shared. Okay. Okay. So even though this is then redefined here, it still works. Okay. Okay. Makes sense. What if I'll do this and say that I want the address of it? Ooh. Okay, so I don't know what address is for anyway, but hey, we learned something. I hope you learned something too, because I don't know how to describe it. It's just I have an idea in my head and I'm just, let's try it, and I'm probing it. Okay, you can copy a sequence passed as argument by value and modify the copy. So procedure do something, we get the sequence. We can copy it, modify it, and get that we changed the new one. Okay, so we had a test one here, we did pass it there, even though it's not a variable one. We did that thing, and the first one has been modified. So yeah, that's the thing that we kind of tested. Alrighty, let's move on to something yet different. Bitsets. Nym comes with a built-in way to build a set of ordinal types. In order for a type to be usable in a bitset, it must be an ordinal, and height t is less than 2 to the 16th. Okay. For sets of non-ordinal types, see the sets module, which contains hash sets. Okay. However, best practice is to keep bit set size significantly smaller, since each possible element in a set consumes 1 bit. Therefore, a bit set of 2 to 16 element will consume over 65,000 bits, which is basically 8 kilobytes. Bit sets have all the useful operations of mathematical sets. A and B is an element, is A element of B. So basically we can say D and A to Z. A not in, then we add, subtract. These are basically sets of some values. So we have those curly brackets, and well, that thing doesn't explain a lot. It's just we have them, and this is the syntax, I guess. So we have from A to Z, subtract from B to D, and we have suddenly from A without this to, and then E to Z. Okay, makes sense. So we can just, okay, 40 is not in from 2 to 20. Huh. I'm sure there are uses for that. It's just the definition of it here is just very little. Okay, we still have a little bit of time today, around 20 minutes. So let's take a peek at files. Reading from a file, because this is suddenly something fun. Suppose we have a file in the same directory as our nym program, kittens.txt, with the following contents: Spitfire, Vivin, and Motor. We can use the read file procedure to read the entire file into memory. Okay, so let entire file is read file kittens.txt. This will read the entire file into the string entire file. Okay, so that returns the string. And we can just print it out. Okay. We can also read the lines of a file by opening a file object and using the read line procedure to read the individual lines. So this is probably a little bit more how it would be actually used. So we create again procedure read kittens. We define a file f by open and kitten.txt. So open basically assumes the file and it doesn't require any imports. Interesting, like always available like that. Close the file object when you are done with it. So we can defer fclose. Oh, that's really nice that we can defer. That's really nice. That's something I'm missing in C#, but I always like was fun in Go. And then we do let first line is f read line. Echo first line. Okay, so we have read line, and we could probably loop over it in some way. Writing to a file. We can write a string to a file using the write file procedure. So again, text is cats are very cool, and we write to a file. This to a cats.txt file. We write the text. This will create a file on the system named cats.txt containing cats are very cool. We can also write a file line by line using a file object and a write line procedure. Okay, so very similar. We specify our lines, 1 word per line. The fmWrite constant specifies that we're opening the file for writing. So again, the same open. And we just specify if writing will be probably read or probably read and write. Okay, I'll copy it to check it. Again, we defer closing it. And for each line we specify, we just write it down. Bam. So let's check what other values are available here. So fm read Does it work? It does. fm read write works as well. And fm write. And if I'll do something weird, yeah. Okay, that's simple. Do we have it specified here? Let me restart this Visual Studio. It's just like every time something happens, it just breaks. Sync IO dot open, and it takes the file mode. Okay, default mode is read only. Okay. Okay, so fmwrite is syncio.filemode.f. Yeah. Too bad we can't just go to that one. Oh well. But hey, that's cool. So wow, that was a really short introduction to files, but I guess we were able to read from a file and save to a file. That's good enough. JSON. NIM's JSON module allows you to work with JSON data. So that's something I'm really interested in, to see how well NIM actually works with JSON data. Because not every language has it done nicely, especially the languages that are not dynamic can be sometimes pain to work with. So, converting data into JSON. The JSON module provides the %* operator, which is used to create JSON objects. Wow, okay. And they are not next to each other on the keyboard either. Which is to create JSON objects. Note that the use of the $sign operator to convert the JSON object to its string representation. Okay, so import JSON. That's easy to remember. Let element is hydrogen and atomic number is 1. So let JSON object, we just put that operator, and we can just shove that right in there. How is that defined? I want to be able to define something where I can suddenly use curly brackets. I like that. So what, do you just have... Yeah, but these need to be defined as strings. That makes sense. And this will insert those values here. Oh, this is fun. And when we echo it, we can stringify it. Just with that, because I guess this returns some kind of type. And that has defined the string. So let's see that, because I think Visual Studio will show us, Visual Studio Code will show us the type of the JSON object. JSON node, okay. So the JSON node suddenly will do that. So do we have this definition here? Yeah. Oh, it's a macro. That's why we can do this little thing, because macros in NIM, I believe, they allow us to just take anything and define like our own language things. Okay. Convert expression to JSON? No, directly. Sorry. Without having to specify the % for every element. Whatever that means. Okay. Very, very, very cool. Parsing and accessing JSON. So we have that JSON object as a string, JSON array as a string. Parsed object is parsed JSON. Okay, so we can basically parse it from the string. So that's an option too. Like, read it from a file or something. Name, and we parse object name and get string. Okay, so I guess we can basically get our parsed object. And we can specify name. I wonder if we can do like, with slash or something to get deeper. But not sure how that would work. For sure we'll copy it in a second to check that. So this will print sky. So we can just print it out. Okay. And the parse array is, we just can parse the whole array, and because it's an array, you can just get some element and specify, because I guess that will be, again, JSON node or something. We can specify, hey, get it as an integer. Assume it's an integer and parse it as that. Okay. The parse JSON method takes in a string representing a JSON object or an array and transforms it into a JSON node. We can access the fields of JSON node object using the square brackets syntax. The procs get int, get float, get string, and get bool are used for converting JSON nodes into enum data types. I presume they can throw errors or exceptions, whatever you call them in here. So let me paste that code and check what's going on here. These are strings. This is a JSON node, and we can specify this. So what if instead of name being like that, I would specify that it's first, and first will be sky, while last will be Smith. Okay, so it should still parse, right? When we run that and we get name, get string, it should error. It just returned nothing. Okay. So it didn't error. Okay. It just returned nothing, as there's no such thing. How does the word name dot first run it? Nope. Now it's just that, hey, there's no such thing. Key not found. Okay. What's the parsed object? Oh wait, this JSON node name string gets field from JObject, which must not be nil. If the value of that name does not exist, raises key error. Okay, so I guess I would need to do name, and then we do first, right? And that should return sky. There we go. If I'll do last, then obviously we'll return Smith. There we go. Okay, that makes sense. And we'll get int and all this stuff works. Get float. Sure, that should work too, right? It was just 8.0. Yep. Makes sense. Okay, this was really easy. And I guess that would also allow for additional inspections, what the type is and what not, and therefore creating packages that, allow to easily, get JSON string and convert it into some kind of object that's already predefined. You would call it a model at that point. All right. Very much fun. Parsing JSON into enum object. There we go. In some cases, you might want to convert from a JSON string directly to an object. Exactly, that's what I need. So again, just our JSON thing. We specify our type, our model, I would say, element, and has name and atomic number. Perfect. And it's an object. Let's say this is the JSON we want to convert, right? We just specify the string in that format, and we say parse JSON. So let JSON object is parse JSON. So right now, we just have it as the node object, or like JSON node, that's the type here. And we can say element 2, JSON object, comma, and element, and we specify the type here. And that's it. That's how we just converted. This will print carbon. There we go. Oh, this is, wow, this is, I think, the simplest I've seen so far. Other than, of course, JavaScript, where you do parse JSON, or whatever it is. JSON.parse. And it just creates a new object, and because JavaScript is dynamic, it just goes whatever. Okay. Next. Varargs. Wow, we've gone through a lot today. Maybe we'll just go through varargs and string formatting, and we'll leave the object-oriented programming parallelism, the fun stuff, for the next stream where we finish it and maybe start coding or doing something with that. That would be fun. Okay. Varargs. Standard varargs simply allow you to pass multiple parameters to your function. Okay. Procedure. Print things. And we say things is varargs of string. Okay. For thing and things. So this is basically like a array of strings, and we can echo those things. So they print things, and we do words to print. Very pleasant. So we can make our own echo. I very much like it. And we'll just print them one by line because we're printing them with echo one by one, so each in a new line. However, trying to run this, print things, and we have integer, then we have a string, and then we have a sequence, will fail to compile because the compiler won't coerce anything into strings. Luckily enough, there is a tool to fix this. The coercing varargs. Ooh. Oh, wow, I really like it. They thought of everything. So print things, and now we have varargs that takes a string, specified as a string, and hey, use that operator to coerce things and, things into strings. And bam, we can do that. Oh, that's exactly what echo does. Huh. I really like it. It works by finding a function blah that returns a string for each argument type and applying it to each argument. Very much like it. So it doesn't need to be an operator. You can just make any kind of procedure and define it for those different types. Ooh, fun. Okay, next, string formatting. The ampersand operator can be used for simple string concatenation. Yeah, that's how we used it so far. The string utils module provides string interpolation from a format string using the percent operator. So let's see, we imported the string utils. In this case, std/string utils rather than just normal string utils. That's interesting. Then numbered arguments, echo, and we have the string with number 1 and number 2, and that basically this operator takes a string on the left, an array of strings, or probably, I wonder if this could be varargs that's being coerced. It takes that and you can fetch the next and it just does that. This is a very interesting approach, because that means that you can just do that right anywhere without calling like format or something. Unreadable for somebody that isn't familiar with the language, but wow, I really like that. You can fetch the next argument using the number. So echo, and they're just, instead of being numbered, they just continue. And can support name arguments. And this is my favorite. First, second. Oh, but you need to specify it like this here. Oh, so I don't like it. Okay. But doable. Yeah, I'd like it if this was like this, but acted like that. So that, it does things. Oh, wow. I have a crazy idea. We'll look at that in a second. But what if I can make my own? Because we are learned enough to make our own operators. So I would take my own operator that first takes this, converts into that, and skips those every second one. you know, every odd one or whatever. No, I mean, it takes this, turns into that behind the scenes, and therefore you can use that. Let's try that. This is fun because it feels like you're not just writing another procedure or something. It feels like you're modifying the language on the fly. So let's see how this is defined. On the left, it's just a string, and on the right is open array string. Interesting, it's an open array. Okay, let's copy that. We'll go the easy route. Let's copy that, and we'll just say procedure, this thing, right? And on the left we have this, on the right we have that, and whatever GC safe is or whatnot, we're not doing anything. And let's define it. Right now it's unhappy because it's not unhappy. Okay. It's just not used yet. So let's say that we take our format string. Oh dear. That means I need to use... Sure. NA94765787 says that they have a random question. It's a funny question, might be entertaining. Let's hope it's not an advertisement. Go for it. Okay. In the meantime, we need to take our format string. If you could choose anyone to see get tickle as a prank, who would it be? I guess that would be a someone well known, so that is actually funny, not just funny for me. My first thought was Elon Musk, because he must be serious, but he's not serious, so that wouldn't be funny. It would need to be somebody that's actually, like, you know, a serious person by normal standards. So, yeah, I don't want to get political here, unfortunately. But, gosh, I'm trying to think of something where it will be... Oh, okay. Had a funny choice. I say Justin Bieber, as he's quite arrogant, as would try to act tough. Okay. I don't know anything about Justin Bieber, just that he exists, and at times when he was initially popular, it was really... I didn't like him just because of his music. But here, I'd say Trump would be funny to see tickled. And he probably wouldn't try to act tough. I have no idea. But that would be funny. Alrighty. Going back to formatting strings. I agree. Could be very entertaining. Okay, so the first thing that we need to do is take the format string and remove, turn all $sign something 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 to to something like that. I wonder. Oh, okay. So I think it wouldn't be that simple, because there's nothing stopping us from doing this. Or first Z, and then we replace first with that thing. But we could just do this, right? Okay, let's give up on that. This is too edge casey. But I think we could do something like, make a double thing here. Okay, let's do the simplified one, where we assume that there's always space, it's always space around it and nothing else. So we could say that will be extract words, right? So this will be let words. Let's do the var. Var words is string dot split, and we split it by spaces only. Can probably do that. Yeah. So with continue with the tickling. Yeah, Trump would be very funny, especially if we will go for a neck. Okay, so we first split our string by spaces, and then okay, these are our words, right? So then what we would need to do, why doesn't it like split? Mismatch. String, then we have separator and max split. Okay. I guess we do it like this. Nope. Doesn't need to be a string. Nope. How the hell did we do split before? Let's look at the examples. I believe that was in strings. Split. Oh, we did that kind of thing. That's not an array, that's something else. I don't even know what that is. It looks like that bit thing. Okay. Save. Still doesn't work. The split procedure takes a sequence of characters and splits a string based on them. A sequence, you say? Let's give it a sequence. Nope. Ay, ay, ay. Separator character. And then it allows for max split, but not really the thing. Oh, why am I doing string? Format string. That's my problem here. Oh dear. Save, and now it works. So we have our words. And then we want to basically replace the ones that are in that format. So let's do for word in words. Let's actually do I, word words, so we get our index too. And basically if the word is there like starts with, and we give it a character of a $sign, then we're gonna replace it. So we're gonna say words and that I equals, and we just give it the one with the number, right? Okay. Oh yeah, we need this thing. And we can just do bam. So that's how we did go through that. So we have the new words that we saved. Then we can basically reassemble it back into a normal string. So let's do let, and we call it a new string. Oh, new input is new format string. And that will be words dot join, and with the separator of a space. Nope, what is join expecting? It expects an open array of strings and a separator, which is a string, not a character. So we could replace those like that, and there we go. Now it works. So we took care of, replace ABC with this thing. And then our second step will be remove all odd entries in arguments. So we can do basically something like for arguments, and that will be of type sequence of strings. And we just say that it's an empty sequence, so we can go with something like for argument in A, as these are the arguments. And let's also get an index. I will say that if I and mod 2 is equal to, so I guess for all the, because they start with 0, 0, 1, 2 in a sequence, they're the indexes. So if it's actually, what do you call it when it's not odd? When it's even, then we actually want to skip that one. So we do continue. But if not, we just do arguments add argument. Okay, this way we're gonna skip this first one and then the second and whatnot. And therefore we should be able to do return. We do a new format string. We do the thingy and arguments. Right? And if we have this thingy, so that means we can, let's just grab this whole thing and put it here at the end. So we have that and our custom one. So we should be able to call this just without those. Save, run. Exception. Without format string. Oh, yeah, because we need to double it. And run again. Nope, failed. Without format string. Oh, it was supposed to be $hash. Okay, that's me being silly. No. S hash. So replace it with that. While here it's expecting as hash. So wait, what's the problem? Invalid format string. Value error. But it did it correctly. Got 2 of them. And that should just work. So right now I'm not sure what's going on. Because this and that should be fine. Well, it says it isn't. So let's take my code. And I have the following code. Just paste it, and then when I run it, I'm getting an error. And let's paste an error here. And the error is, let's actually do this whole thing here. What is happening? Send. Come on. The error occurs because the $sign operator expects numbered arguments or named arguments in the format string, but you're passing this as the format specified and modified. To fix this, you can modify the procedure to replace this with that instead of... Huh? So it probably goes with a completely different method. Oh, okay. What the bleep? That is strange. Did something happen to my audio? Not sure. Showing as if there was a problem with my audio. At least on YouTube. Oh well. If you can't hear me, but you can see me saying something, please let me know in the chat. Okay. I guess you will let me in a chat because you won't let me know in the chat because you see me talking, but there's no sound for you. Oh well. So this didn't do anything correct here. Because this was dumb. Very, very dumb. Because I can do the numbered ones, right? But I can also do that. No problem. So I don't know why it doesn't work. Unless I mess something here. Mess something up. Let's do something like echo or debug echo. Because we are in no side effects. Debug echo, and we'll just do the arguments. And we'll do the arguments. And let's see if this will give us something. Arguments is just world. Which... Oh. Yeah. Why does it have just world? Oh, I am so dumb. Because I don't need to remove those. Yep. That's it. This whole thing goes away. Oh. I am so dumb. Save. Run. There we go. Now it goes well. So I can do first, second, and we'll do third, right? And we'll just add cruel in the middle and run it. And now we have hello cruel world. That's perfect. So yeah, we can easily make our own operator to just modify how it works. I really like it, but I am sure there are better ways to do it than what I did here. So let's see what's next in the tutorial. We were inside the string formatting. We went through that. And then we have, alternatively, you can use the functionality provided by the string format module. So we import the string format. We have H is hello, W is world, and we do echo format. Take H, we can take W, and it just magically fills it in. So this is like, you know, Oh. Okay, so this is something like you would expect when working with I forgot the name. Like in JavaScript where you have $, or yeah, $, in front of the thing. Now I'm mixing up C# and C++, but you know, this is simple. I just text it from there. Awesome. The format and the ampersand operator have a slight difference in usage. Namely, the format operator results in a raw string literal, which does not interpret escape sequences. Using the ampersand operator is the simplest way around this. Other options are listed in the docs. I really like this one. This is so much fun. Wow. So simple. Non-string arguments. We have seen 3 different string formatting options above. How do you format non-string built-in types? So I have string utils and std string format. We have number 42. If we'll want to do hello and number, it won't work exactly. I mean, because we're concatenating, yeah. This does not work either. Hello, and then we have the first argument provided number. Yep, because we saw that it expects a string. Well, this works fine. Okay. So use the $sign operator to convert to string. Assert this is that. Yep. We know that that's how we can convert. So yeah, we can do this and we can do that. Yep, makes sense. That is the first 2 methods. The first 2 methods expect string arguments. The third works with any types. Refer to the docs for format specifiers for alignments, integer and floating presentation types. Yep, the standard things. I'm not gonna read through all that. It's easy to look up when you need it. Formatting object types. The $sign operator enums version of the string or toString function. Oh, is enums version. Okay. You can create string representations for object types as shown below. So we just string util, string format, and we can say fruit is an object that has name and color. So we can define $sign operator on the fruit, and we say self. I like that. Just instead of this, or you just have self. Okay. And returns a string. Exactly. And we just use that ampersand operator to just format it. Fruit. Bam. Self. This and that. We can just echo it. And that will work. And that will work the same because echo is already calling it that way. Okay. And echo we can does not work. Okay. Because we have the ampersand, we need to remember the $sign. Yep. And this doesn't work, but with an ampersand it works, and this works. They both work. Oh, wait. Note the difference here. We do hello apple, it will kind of format it on its own, like an object. So this is using some other formatting things. It isn't calling this like echo does. Huh. That is very good to know. Note that the first line in the last section formats object types and other types using the inbuilt representation. And you need to use the $sign operator as in the second line of the last section. If you want to coerce it into format of your choosing. Okay, so this is this REPR, right? So let's grab this. And I think I know what it is about. So let's see. We save it, and yeah, these won't work. Let's just ignore it all. I should be able to have a difference here. What do we do? Echo apple. We're just gonna get fruit, apples, red. That's it. But we can do also echo REPR, right? Apple. Save. So I mean, this is something like that. and run it. And this will say fruit, name apple, color red. So it's yet different than did that. This did. So I can have a third version when I do just that. It'll be also different. Oh. That's not what doc says. So I guess because this is supposed to apple, yeah. So I did that, and it should print it just like that. So it was expecting just that part, but really it used the $sign. So maybe it changed in some version. This might be an old article. Okay. So everything works, in a little bit more specific way. Okay, this will be long, the whole object-oriented programming, but we finished for now because it's getting late here. And yeah, I mean, we went through a lot. And we'll have object-oriented programming. Let's just peruse what we'll have here. Member functions on method calls. I guess it just explains that we can call it that way. That's all good. Okay, we'll see how that works. Inheritance, implicitly final, all other stuff. Very interesting. And we have new keyword method. Okay, cool, exciting. And should use proc or method, subtypes. Cool. Next thing after that, we parallelism. Different compilation with specifying threads. Like, hey, this is a thread. Create thread, all that stuff. Fun. Using a thread pool. Okay. Oh, these are really short. Then we have channels, which looks like we'll be able to send and open, all that. So just like in Go. Then we have concurrency with await, async await, which I absolutely love working with async await stuff. And hey, this is async. We can use await, wait for this and that. Oh, that's fun. I really like that. And yeah. And at the end, we'll have the big scary macros, which we have something here. Here. To get that nice notation, we can use a macro. Cat body, they're on type. Okay, this will be very different. Yep. Okay, that'll be a fun finish. Cool. So on Friday, we'll start with object-oriented programming, and I think we'll be able to go through it all fairly quickly, maybe an hour, hour and a half, and then we'll do something else for an hour and a half. I think we'll start actually setting up the project for the little library that will be specifically for managing, for allowing like a library that will provide an abstraction layer for interacting with actual file system or maybe like in-memory file system, and will allow for others to create additional libraries to interface with something like S3 buckets or FTP or whatever else. And all those would be accessed in the same way through the same interface. So, your application that uses the library could easily have the same code, no matter if you're using files on your hard drive or you're using S3 buckets or maybe just in memory. So maybe we'll start that on Friday. That would be fun. Okay, so that'll be it on my side. Thank you for watching. And again, I'll slice this whole video into smaller videos that focus on specific chapters of the tutorial and whatnot. It will just take a few days for them to be released. So thank you again and have a wonderful day or night.